Yes, welcome. This is lesson 4 of science under the topic machines and friction. In our lesson 3, we looked at levers and we defined levers as a rigid bar turning freely at a fixed point called pivot or fulcrum. We went ahead and classified levers or levers, where we talked about first class lever, second class lever, and the third class lever. In our lesson 4, we are going to look at second class levers. With second class levers, the load is between, or the load is located between the fulcrum and the effort. And therefore, they are used in lifting they can be used in lifting big objects. Why? Because the distance between the effort and the fulcrum, which is abbreviated as EA, or it is known as effort arm, is longer compared to the distance between the load and the fulcrum. So less effort is used, or less effort is applied to carry a big object. My dear learners, for example, I have some machines here that belong to second class levers. Here I have a bottle opener, which is actually an example of a second class lever, which can be used to make work easier for opening a bottle top. For example, I have this bottle opener. The effort is applied around here. So when I want to open this bottle top, the fulcrum is around here. The fulcrum is around here. So what I do is I simply open the bottle top and I drink my soda. We also have an example of wheelbarrow. We have wheelbarrows. We have crowbar. And lastly, we have a nutcracker. Some of the machines I do not have with me are being drawn on a chart that I have here. I have a chart here which show examples of machines that fall under second class lever. I have a wheelbarrow, a nutcracker, a crowbar, and a bottle opener. My dear learner, I also want us to look at third class lever. In third class levers, the effort is between the pivot and the load. In third class levers, the distance between the load and the fulcrum is greater than the distance between the effort and the fulcrum. The distance between the load and the fulcrum is known as the load arm. It is abbreviated as LA. The distance between the effort and the fulcrum is known as the effort arm. It is abbreviated as the EA. We have examples of machines that belong to third class levers, which include pair of tongs. For example, I have a pair of tongs here. Locally, they are used by our grandfathers in the villages for plucking beards. They are used for plucking beards. I also have what we call tweezers. This is locally made, but it is commonly used by medical workers when they are operating patients. They use them for stitching. For example, they have certain objects that they use, or they hold it here, and use for stitching a wound or a broken part of the skin or of the body. Another example of third class levers that we have is a fishing rod. Those of us who live, or those of you who live along river banks or the lake shores, I'm sure you know what a fishing rod is. The fishing rod, the fulcrum is applied around here. The fulcrum is located around here, and the effort is applied where my left hand is. And then the Lord is here, where the fisherman or a fisherman places a bait around here and dips it into water. So when the fish catches the bait, the effort is felt, the Lord is felt around the effort, and then the fisherman removes the fish. We also have spare, which belong to third class levers. And lastly, we have the human arm, where the fulcrum is around here, the effort is around here, and the load is placed around here. For example, I have this object to carry, the load is felt here, I apply my effort from here, and this is the fulcrum. I carry it. My dear learners, we have a chart from where you will have to draw. You will have to draw the examples of third class levers. How do you know that the effort is in between, or how do you know that this machine belongs to first class lever? We normally use a formula PLE, where the pivot, where the P stands for pivot, L stands for load, and E stands for effort. So if they draw for you something of this nature, representing a machine where the fulcrum is here, load is here, and the effort is here. This is what we call the effort arm. This is what we call load arm. So, to which class of lever does this machine belong? We use the formula PLE. Therefore, you say, if the fulcrum or the pivot is in between the load and effort, that is first class lever. If the load is in between the fulcrum or the pivot and effort, the fulcrum or pivot and the effort, we say this is second class levers. And lastly, if the effort is in between the pivot and the load, we say this is third class lever. So, to which class of lever does this machine belong? Here, the load is in between effort and the fulcrum. So, where is it? The load is in between effort and the fulcrum. So, this machine belongs to second class levers. Dear learners, I advise you to draw these machines. You should be able to define what second class levers are and the third class levers. See you in lesson 5. Thank you for watching.